So the bearing of the sun changes over the course of the day. Obviously, you can watch that happen yourself. Um, and what that means is that a LOP you get from a sun line will change the angle that it's ultimately lying along, because an LOP is perpendicular to the azimuth, which is the bearing of the sun. So you'll see the sun's LOP slowly shift from vertical to horizontal, and then back to vertical over the course of the day. And if you remember from TNAV, whenever you're getting a fix, whenever you're measuring, comparing LOPs against each other, you want a separation of like at least 60 degrees. If you can see, let me zoom in a bit. At least 60 degrees like that. Because if you had a separation of, I don't know, 10 degrees, it's going to look like that. And that's not any good to you. You don't know whether you're here, here, or here. And obviously both of these are only involving one line. But if we add a third line with 60-degree separation, we get a really clean fix right here. Whereas if we add another line with 10 degrees, that doesn't really help us anymore. We're still just as unclear. So you want a decent separation between LOPs in CellNav as well. Now, we can't necessarily get 60 degrees every time because the sun moves really slowly. The standard practice is to give it a good at least 2 hours between your sun lines. That'll have enough swing in the bearing of the sun that you'll get a pretty good difference between the two LOPs. That also, however, means, though, is that you've just waited 2 hours, meaning you've moved in between those 2 hours. So you have to perform a running fix to actually advance them to one another. Because it's a 2 hour difference, you're usually only going to be able to get 2 sun lines in the morning and 2 in the afternoon. Even if the sun rises at 6 a.m., if you remember before, let me grab the Nautical Almanac, you really don't want to take the measurement of any body that's less than 10 degrees in terms of its height in the sky, because then you have to deal with all of this and this stuff right over here. It just becomes less accurate. So you want to wait till it's a decent height in the sky. And as a result, normally you shouldn't take a sun line earlier than like 8 in the morning. 8 if you're using your actual local mean time. Right around then, it should be high enough that it's a reasonable fix. I mean, you could get one around 8 a.m., one around 10 a.m., and then you run into an issue at noon, because at 12, which is close to exactly perfect high noon, you get into a different type of sun line called an LAN line that we'll get into later. It's actually easier. It actually helps you a lot. It's really good to take a shot at noon, but you haven't learned how to do that yet, so we're not going to touch on it. Meaning you can only get 2 normal sun lines in the morning if you're doing everything properly. And as a result, you would probably advance them to that LAN line you get at noon, so you get 3 lines of position in a perfect fix. Now, we're just going to quickly review that so that later we can learn how to put it all together and get one large day's work where we're running through all of those up to noon and through till the afternoon, including the stars if we want to do the stars. But for now, we're just going to review, if you have 2 sun lines, how you advance one to the other. So this is our June 4th problem that we did before, and I just added in an additional sun line. This is not accurate in any way. I just drew an arbitrary line where it generally should be and at the angle that it generally should be if I shot it at 1120. So don't assume that this is correct, but this can be representative of what we're doing here. Now, what I left out here is a DR position at 1120, which is something you should take, because whenever you're doing the math work for working out a sun line, you need a DR position anyway. So before you ever plotted this, there should have been one on the chart. I left that out intentionally so that we can do it now, but remember, you'd have to do it beforehand. So we're going to do the calculations. If we shot this at 1120, then we need the difference in time between 9:15 and 11:20, which is 9:15 to 11:15 is 2 hours, so just 2 hours and 5 minutes. So we'll do 2 times 60 plus 5, we get 125 minutes. It says right here we're going at 13 knots. So if you remember 60D Street, we take our difference in time in minutes, multiply it by our speed, and then divide that by 60, and that'll get the distance that we sailed between 9:15 and 11:20. So we got 27.08 miles. So 27.1 miles is still not measurable. We'll just work out 27 here on the distance scale, which is the same as latitude, right there. And then we mark 27 minutes ahead of 9:15. Place that down and write 11:20 diagonally because it's DR position. Now that we have that, we can actually do our advancement. And it is convenient when you do this before you plot the LOP because you don't have to do any more calculations. Now you know that the difference between these 2 points is the same distance that you would have traveled from somewhere on this LOP in this direction. Remember when we did our running fix video back in TNAV, all the running fix means is that you traveled this way at that speed going this far, and whether you were here, here, or here, you still went that far in that direction. So it creates a parallel line in that distance away down the line. So how we make this running fix is we measure the distance like that, place one tine at where the 9:15 sun line intersects the track line, find where the other tine hits the track line, make a little tick mark, and you take your triangles, you set, just go there. You set one triangle parallel to the 9:15 LOP. Place your other triangle underneath so you can slide them over. Slide them to where they are, where your tick mark was. And draw your parallel line. Now, how you want to label this, because you want to make it clear that you had a running fix here, is you do lower limit of the sun at 0915 dash 1120, which means it's your 9:15 sun line advanced to the time that you should have, where you should have been at 11:20. And this is now a valid LOP for 11:20, more or less. Where the two intersect, you can see here's your 9:15 advanced sun line and here's your 11:20 sun line. They intersect right here. Now, you shouldn't call this a fix because it's only two LOPs. These two lines, they're not parallel, so they were going to intersect somewhere, anywhere. Doesn't matter what two lines they are, they will intersect somewhere. As you can see, it intersects the original line right here. That doesn't mean anything, though, because they're two unrelated lines. So you can't say with any confidence that that right there is your fix. But if we were to later get a third LOP somewhere down here, and we advanced these two up to it, and they formed a pinwheel between the three, that would be a really good running fix. So this wasn't to show you a full fix, it's just to show you advancing lines in time, so that when later we get to the step where we're doing a full day's work, you'll be more equipped for that immediately.